I'm an explorer, you're an explorer.
So we are standing right between two different landforms. So here, where we're standing, we are between the floodplain, which is over here, and that's where there's a lot more water. It's wetter soil. And then we have the uplands, or the bluff region of the park, over on this side. And it's a lot drier. The plants that you find there, the trees that you find there, they're very different. There might be more plants in the floodplain than you might find up here in the bluff and upland region of the park. Now, these two landforms are really important for you to remember. So I have a little way for you to remember the difference between the bottomland, the upland, and the bluff that separates them. So you can stand up and do this with me if you want. So we'll do it 2 times just so you can learn it the first time and then you can do it with me. The first thing you're gonna do is put your hands on your hips and you're gonna say a bluff, and then you're gonna take your hands and say, raise them up like this and say, is a hill. Take your hands like this and then say, that separates the Upland Forest from the Bottomland Forest. So make your voice go high for the up and low for the bottom. So let's do that all together at the same time. We're gonna put all those things together. So do it with me. Hands on your hips. A bluff is a hill that separates the Upland Forest from the Bottomland Forest. Do you think you can remember the difference now? Do you think you know what a bluff is? If your teacher asked you, do you think you know what separates a floodplain and an upland? I think you might have it. Now, floodplains, they're right along rivers, and rivers are a great way to move soil from one place to the next. You remember what that process is called that leaves soil behind? It's deposition. Deposition happens in the floodplain all the time because it floods often, maybe sometimes 10 or more times a year. And sometimes the floods are really small floods. They're not really big, but every flood is dropping off soil. The soil has traveled a long way. We have different regions here in South Carolina, and the soil is traveling from one region to the next region. And it just keeps traveling over time. Now, you can kind of see on this map here, those regions of South Carolina. Up in the upstate, up in that top corner, we have the mountains, the Blue Ridge. And it's a very tiny sliver of the state, but it's very important because that's where a lot of our soil starts. Because mountains are made out of lots of rock. And that rock is going to weather and break down into smaller and smaller pieces, becoming sand and silt and clay. And so that water that breaks apart those rocks, it's gonna carry those pieces of soil downhill out of the mountains. And it's gonna go into our next region, which is the Piedmont. This is a big region. And the Piedmont stretches from the edge of the mountains all the way down to the next region, which is the sand hills. Now the sand hills is a really thin line that runs from up near North Carolina's border with South Carolina all the way down to Georgia's border with South Carolina. And it isn't typically more than 10 miles wide. It's very thin. But that is where the ocean used to be many, many, many years ago. And it deposited lots of sand there. And the fall line is right in the sand hills. And that's where we go from the Piedmont into the upper coastal plain or the inner coastal plain. And so that is where Congaree is. We are in the inner coastal plain. So we are in this region where the land starts to really get flat And rivers, they don't cut deep, deep, deep holes into the ground, what we call gorges, but they just flatten out and they move in big, long, snaky lines. And then from the inner coastal plain, we go to the outer coastal plain, and that is where you see it get even flatter. And then eventually you get down to where we call the low country here in South Carolina, and that is the coastal zone. And that is where you find beaches and marshes, and it's really flat. And that's where all that soil is eventually gonna end up going either into those marshes, or the sand gets left behind and leaves you beaches. So those zones are how soil travels from the mountains all the way down to the ocean. And it stops right here for a little bit, for a small period of time. How does that all happen? How does soil get carried by water and deposited someplace else? Well, I have this really cool bottle right here, and it's got the 4 parts of soil right inside of it. I've got sand, I've got silt, I've got clay, and I've got humus inside this bottle. Now, if I gave this enough time, this water would actually look really, really, really clear, because all the pieces of soil that are still kind of floating in the water would eventually drop down to the bottom. But if you look at this bottle, it's a lot cloudier because it's been mixed up. And you can see that those little pieces of soil, most of it is clay, are still floating around in the water. So let's just show how soil gets transported from the mountains to where we are by water. So let's just imagine we're up in the mountains and it begins to rain, and we start getting that process called weathering. And so it just starts to break down the water, break down the rock little bit by little bit. It's really gentle. It takes a long time. But sometimes you get heavier rains and you get floods that kind of push more water down streams and creeks into rivers. And so it starts to go a little bit faster, a little bit stronger. And those rocks that had broken off of the mountains, they get broken up even more. And then as the water gets to going even faster, it's really churning everything up. And then let's just say we get a big flood, and it's really going, and it's really taking everything and stirring it up. But then in a floodplain, it slows down, and all of that soil begins to fall out of the water and begin to fall to the bottom of a river or a floodplain. And so the first thing to fall out is the sand, and then the silt and the clay, they'll begin to settle down. And eventually, if the water isn't flowing where that water has left the soil, it will just look clear. So if you make one of these shaker bottles and you make it with the sand and the silt and the clay and the humus, shake it up and then see how long it takes for the water to get clear. It might take a really short amount of time for most of the soil parts to fall out to the bottom, but it'll still look kind of like chocolate milk for a while, until finally all of it settles down to the bottom and the water will look much clearer. But if you do that experiment, maybe time it. Try and see how long it takes. Does it take a couple hours? Does it take a couple days? Maybe a couple weeks? It's a really fun experiment that you can do, and you can see all those processes, weathering, erosion, and deposition, all in one little bottle. So now that we've seen how soil gets transported and moved from one place to the other, we're gonna go see what it looks like underground after it's been left in layers over time.